So today we're going to explore this relationship that we talked about on the first day, about how the sine of one acute angle in a right triangle and the cosine of the opposite acute angle in a right triangle will always share the same answer. They are called co-function relationships, and co-function partners are two functions, two trig functions, that share the same name the same answer, and have complementary angles. Now that means we can exploit that from three different directions. If I know that two functions have the same answer and they happen to be co-functions, I'll be able to say that the two angles that I was dealing with, they must be complements. If I know that two angles are complements, I can pick any two co-functions and say that they'll have the same answer. And if I know that I have two angles that are complements, I can say that the two co-functions that are given to me will guarantee the same answer. These are your sets of co-functions. They're really three of the same sets. They've just come to you in pairs. These two say exactly the same thing. It's just in the first one, the sine is the upper corner and the cosine is the lower one. And in the second one, I've reversed the order. These two are also co-function partners, and you can tell co-function partners because they share the same name, tangent and cotangent. Tangent and cotangent are the only two trig functions that are actually partners in just about all crimes. They were also reciprocal partners, where sine and cosine were not reciprocal partners. And here's your last set of co-function partners. I point out the reciprocal partners because this is where it starts to get tricky. Now I've got two different relationships to keep track of. When I'm talking reciprocals, take the answer and invert it. Sine goes with cosecant. When I'm talking co-function partners, same answer for complementary angles. Sine goes with cosine. Are you clear on the difference? I'm going to talk about it a lot more, but you need to keep those two relationships straight. It's very important. So sine goes with cosine. Co-function partners are called co-function partners because basically all these secondary functions start with the word co. Tangent goes with cotangent, and secant goes with cosecant. And I'm trying to emphasize the co here because it's also part of the word complement. Complementary angles are also related to co-function partners here. So if you can just keep in mind that when you think of complement, think co-function. And that means that one of the two functions is going to have the co in front of it, and the other one's going to be the same exact word without the co. A little bit hard to see there because I'd used the black. Sorry, JS. All right, so generally speaking, there's not supposed to be an E here. What you're going to do with this is primarily, for starters, to find a missing angle. So I'm going to look at this question and I'm going to say, okay, these are co-function partners, sine and cosine. They have the same answer. How do I know? There's an equal sign there. That means the third attribute that I highlighted up here at the top, they have the same answer, they share the same name. This attribute must be true. So everybody see where I'm getting that from? So if two of the three attributes are given to you as true, share the same name, have the same answer, then you can jump straight to the third attribute and say, so those two angles have to add up to 90. Those two angles must be complements. Once you get that far, it's uber easy. Theta is 80. Hardest part about co-function partnerships is remembering that that is a relationship that you can exploit. This is a question that is almost regularly on the Regents, But it's a question that a lot of kids get wrong because they just forget when they look at something like this that they know something about those two functions. It's an easy detail to miss. So let's try a few more. This one's also going to be pretty easy. I see tangent and cotangent. I'm hearing the same name. I see that they have the same answer, and so that third relationship is also going to be true, that the two angles must be complements. So I write a statement that basically says the two angles are complements. That statement is two angles that add up to 90, and I can find the other angle. The other angle would be 42. Thank you, Alicia. Now, it gets a little bit harder when I get into degrees, minutes, and seconds, but as is always the case, they are going to throw harder questions in there. But I'm going to do exactly the same thing. They give me a cosecant and a secant. I'm hearing the same name. They give me two answers that are the same. I'm seeing the equal sign. So I jump straight to the third assumption that means that the two angles that they gave me must add up to 90. So what is it that's harder about this one? Well, largely that there's degrees, minutes, and seconds involved. So let's talk about the algebra of how I would physically go through and find theta. What do I need to do algebraically? Simple algebraic single step move. I'm going to subtract 85 degrees, 6 minutes from both sides. So I'm going to go to my calculator, and on my handy dandy calculator I am going to type 90 minus 85 second apps enter, 6 second apps, was it 4? Oh, sorry. No, you're right. 2. I'm looking for that. All right, so now I've got the equation all written out there. The problem is when I get that answer, it doesn't look like what they gave me. So now what do I need to do?
Second apps 4.
I need to DMS it. I need to second apps 4. So I'm going to second apps 4 that answer, and I'll get the correct answer, which is 454. Now, just frame of reference, that works. Theta is 454. But in my personal humble opinion, that was a whole lot of cotton picking buttons to push when I could have used third grade math. Third grade math would have looked like this. I have 90 degrees and I want to subtract 85 degrees, 6 minutes. I have something here that I'm subtracting from nothing. So I will borrow and replace and subtract and subtract. And in my opinion, that third grade math was easier than all those calculator keystrokes. You get to pick which way you like better, but just be aware that if I take your calculator away from you, and you're really not supposed to have a calculator, you would be expected to be able to do this. It's kind of comical, isn't it? Take a little bit. Okay, would you try example 4 on your own, please? How'd you do?
Great.
Excellent. Okay, something to keep in mind. These are questions that in this particular case asked for x. If they asked for the measures of the angles, you wouldn't be done. What else would you need to do if that question said find the measures of both angles? You'd need to plug back in. So you've got one of them. This one would be done, but this one over here would need to have 20 added to it, and the second angle would be a 55. But reading for detail, making sure you're answering the question that they're asked, as is always the case, is still going to be true here. Last but not least, would you try example 5 on your own? How'd you do on that one? Great. Excellent. Okay, the next thing we're going to do is we're going to take that knowledge and we're going to tie it on to something we've already done. In the past, we have taken angles and rewritten them as functions of other angles that were positive and acute. So just a quick recap of what that looks like. This is from 2 blocks ago. I could have asked you to rewrite tan 315 as a function, I'm going to abbreviate here, of a positive acute angle. And if I asked you to do that, your job would have been to start by saying 315 is a 4th quadrant angle. In the 4th quadrant, tangent is Negative, so you'd write a negative. You'd keep the same function because I asked you to write your answer as a function. So I'd still write tangent. And now I'd be looking for the reference angle in quadrant 4 that lands or terminates at the same place as 315. And that angle would be 45. Now, what we just did here, we did 2 blocks ago. What we're going to do today is take that same process and apply it to angles that are not less than 45. So if I got down to a point where I was at tan 72, but the directions said rewrite the function as a function of a positive acute angle that happens to be less than 45 degrees, this is not good enough. It's positive and acute, but not really small acute. Not acute enough. So what could I do then? Well, in that case, I'm going to exploit the concept of cofunction partners. Because 72 happens to be a complement to 18, and tan happens to be a cofunction with cotan. That means that the tangent of 72 and the cotangent of 18 would have the same answers. So everybody see where I got that from? Okay, let's try another one. Let's try cosine of 67. Once again, 67 is not small enough. So I need to find the complement for 67. It'd be 23. And I need to find the cofunction for the cosine function. And that would be sine. And that means that the cosine of 67 and the sine of 23 would have the same answer. Still good? All right, what would I do if I were given the sine of 39? I would leave it alone. Anybody in here find themselves thinking just now what the complement of 39 was? Come on. And you were thinking about it, weren't you? Because you get in this pattern of doing the same thing over and over again. One of the things I'm trying to teach you is to pay attention to details. And the detail in this particular question is that I'm looking for an angle that's less than 45. Hello? I gave you one. What should you be doing with that? Nothing. Don't touch it. That one is fine just the way it is. So really the first thing I want you to be thinking about is, should I do something? Do I need to do something? So let's try the last one. This one does need to change. The complement of 89 is a 1, and the cofunction to the secant function is the cosecant. Okay, last but not least, now we're going to take bigger angles. These were all acute to begin with. With the bigger angles, I'm really going to start with the process I did up here. And then when I get down to this stage, I'm going to jump to cofunctions. Now I'm going to write this out in steps because this has one attribute that is uber confusing. And I'll show you what it is right now. This is exactly the type of the question that is going to have these attributes, so I'm going to write the directions and do this question at the same time. The first thing I want you to do is choose positive or negative based on quadrant. 275 is in quadrant 4, and that means that this answer will be negative. Once you've decided whether you're going to have a positive or negative answer, don't change your mind. It's negative. Next, you're going to go ahead and you're going to keep the function, but find the reference angle. So I'll be working with the sine of a reference to 275. The reference to 275 is is 85. Third, you're going to kind of compare that 85 to see, is it bigger than 45? If it is, you have some work to do. If it's not, you're going to stop. I have some work to do. So I'm going to switch to the complement. And switch to the cofunction. So the complement of 85 would be 5. The cofunction would be cosine. So my answer is going to be the negative cosine of 5. Why does this get hairy? 275 in quadrant 4, cosine is positive. So should I really have that negative?
Yeah.
Do you remember me growling at